it's one of the more commonly used algorithms because it's very intuitive. You could really understand how it works, at least conceptually, because it's essentially a tree wherein for each node you have a question. And if it's a yes, then you go to the left one. And if it's a no, then you go to the right subtree. That's really it, at least conceptually. So say, for example, for this particular sample, we first ask the question, is Outlook overcast? Since in this sample, it's yes, we go to this subtree, and then we ask another question, is humidity high? No, no, humidity normal. It's not high, yes, it's normal. So no, go here, play. So yeah, that's how decision tree works. But how does it do that? How does it come up with that queries? How does it know when basically how does it know which among all the values of all the features that it has, which among them should it use for the question here? I mean, it could be, is Outlook rainy, is Outlook sunny, or is humidity normal or low? Why is it high? Right? But before that, let's okay, mention the jargons that we're going to use. Oh, so the leaf node is the decision. Of course, this is the root node. And the internal nodes are the queries. So the questions that we are asking the model. Yeah. And the main question really is, how do we select the queries? For example, you have this, right? We could visualize that as something like this because we only have two features. We plot it into 2D space. The what's this? The y-axis is the score, and then the x-axis is age. We just plot them, and this is what it will look like. If we have this particular query, is age greater than 25 from this data set? We'll have this, right? It's a very simple problem. If you're less than 25, then you're a winner. That's your class. If not, you're not a winner, right? Or we could have another way of asking things. We could use another tree. Instead of that, instead of is age greater than 25, we could have this is score greater than 20. If yes, then it's a winner. If no, then you have another question. Is age greater than 20? Yes or no? Let's visualize that. So if the score is greater than 20, then it's gonna be winner class. If no, you ask another question, is age greater than 20? If it is greater than 20, it's not a winner. If no, this is no, then you're a winner, right? Compared to the previous one, which do you think is better? Let's show it again. This one or this one? Do you think the right one is better? Why is that? Explain, what do you mean criteria? Why is the right one this one, right? Or you have more questions. Why is it better compared to this one? What do you mean by criteria? But yeah, we'll cover that criteria stuff later. We'll show different criteria that we could use for evaluating this model. Okay. Any other thoughts? Who among you guys think this is better? Because some of you think the right one is better. How about the left one? Who thinks left one is better? Okay, interesting thoughts. Right one is better because it provides more information about the data. Okay, the real answer is this: is it's the left one, not the right one. Basically, the main rule that we have in ML, the less features that you have, the less steps that you have to take in order to achieve your goal, the better the model is. If you look at the two, we'll end up with perfect accuracy for this specific data set. Using this tree, we'll know that this particular point here, this x, is a not a winner class, and the other ones are winner, right? They're winners. So, but if we use this one, the left tree, we'll end up with the same thing, but with fewer questions. We just have one question, and we end up with the same thing. You get the idea? Did you get that, or do you need more examples? Because that's a very important concept. Less features, but we ended up with perfect accuracy. Is there another example here? I forgot. Let me see. Do we have another example after that? Yeah, this. Well, it's just another. Yeah, it's another example. Okay, right. Um. Okay. Um. We could have the same results, but with different questions. For example, we ask first if the age is greater than 20. If it is greater than 20, sorry, if it's not greater than 20, then you're a winner, right? That's it. If it is, we now have another question. If the age is greater than 32, if it is, then it's a winner class. If it's not, then not a winner class. So you see, different questions will have different splitting, right? For this tree, you'll have this. For this tree here, when we ask, is the score greater than 20? And if the age is greater than 20, the splitting is this. And for the first tree that we have, the the best one, we have this, right? But again, for this one, the last example, we have additional data point, so that's why it has a different. We have different questions because we have another data point, and because we introduced that, we have to handle that case, this additional green point here. So we had that another subtree for asking questions. Did you get it? Okay. But what if we have this data set? We have plus here in the next. What do you think? What are your thoughts? What if we use the decision tree for this one? Do you think this is an easy problem? Not sure if you're hearing the dots. Never mind that. Um, but yeah, for this particular data set, it would be better if we use linear models such as linear regression, logistic regression, SVM. But for decision tree, we can't. Well, we could, but it's not efficient. Why? Um, this is what it will look like if you use decision tree. So you will have so many splits. You can have that nice line, nice slope that you have in the regression here. It's gonna be like this. So many splits. in order to approximate that line, you're going to have that many splits. Understood? So yeah, different characteristic of your data will require you to use different models. So the maximum possible queries that you could have is d times n, wherein d is the number of features that you have, and n is the number of samples per data set, which is very big. So basically, your whole table, your whole input matrix, that's the maximum number of possible splits or queries. But that's inefficient. We don't want that. We don't want to ask all possible questions because it's going to be overfitting. You're going to have a specific answer for a very specific combination of data, right? So what's the question again? Sorry. How do we select the best queries?